എല്ലാവർക്കും നമസ്കാരം. നമ്മുടെ ട്രെയിനിങ്ങിൻ്റെ അടുത്ത ഒരു ദിവസത്തേക്ക് നമ്മൾ കടക്കുകയാണ്. ഇന്ന് നമ്മൾ കുറച്ച് നേരത്തെയാണ് അറിയാം, പക്ഷേ എന്നാലും നമ്മുടെ ഒരു ടൈം ലിമിറ്റേഷൻ വെച്ചിട്ട് എനിക്ക് തോന്നുന്നു 79 ആളോളം കയറിയിട്ടുണ്ട്. എന്തായാലും നമ്മുടെ സെഷൻ ഇന്ന് സ്റ്റാർട്ട് ചെയ്യാം. ഇന്നത്തെ നമ്മുടെ സെഷൻ പ്ലാനിങ് ഓഫ് സസ്റ്റൈനബിൾ കോസ്റ്റൽ പ്രൊട്ടക്ഷൻ സ്ട്രാറ്റജീസ് എന്ന ഒരു സബ്ജക്റ്റോട് കൂടിയാണ് നമ്മളിന്ന് ക്ലാസ് തുടങ്ങുന്നത്. നമുക്കിന്ന് ക്ലാസ് എടുക്കാനായിട്ട് എത്തിച്ചേർന്നിട്ടുള്ളത് ഡോക്ടർ ജോസഫ് മാത്യു സാറാണ്. സാറ് ADB കൺസൾട്ടൻ്റ് ആണ്. സാറിൻ്റെ ഒരു ബയോഡേറ്റ നമുക്കൊന്ന് നോക്കാം. Dr. Joseph Mathew specializes in coastal processes and coastal protection measures. Dr. Mathew's academic background includes a PhD from University of Waikato, New Zealand, and a PhD in Marine Science from Cochin University of Science and Technology. Dr. Mathew has consulted and researched both tropical and subtropical regions for decades. He has a wealth of experience in the field of coastal processes and coastal protection measures. He has worked on several coastal projects in India, New Zealand, Australia, Europe, the US, and Indonesia. Dr. Mathew's recent coastal projects includes the design and implementation of coastal protection projects in Karnataka, Maharashtra, and Pondicherry. He was a key member of recent ADB Technical Assistant Project, which developed the reference manual on climate change adaptation guidelines for coastal protection and management in India. Presently, he is supporting the Kerala Irrigation Department in their coastal protection planning. Dr. Mathew has produced several national and international journal publications and is the author of many technical reports. With great honor and pleasure, we welcome you to this session. Sir, please.
Thank you. Can I start?
Yes, sir. Yes, sir. Yes.
Okay. Let me share my screen. I hope it is visible to everyone, the full screen.
It's visible.
Okay. Yeah. Okay, anyway, good evening to everyone, and congratulations to the young engineers who are selected to opt this challenging job, not only coastal protection, irrigation, dam safety, and other needs of the state. So I've gone through the schedule of this training, and was really impressed with the variety of subjects included. Of course, it's for a month, and you should be really thankful to the government for organizing such wonderful programs early in the career, which means that if you're interested, you can develop your career to in a very, very balanced way and reach up to the top level towards your end of the career. Anyway, let us start. It's a really good evening here, a beautiful day in Trivandrum. I'm sitting in Trivandrum now. Blue sky and nice breeze and about 30 degrees temperature. Beautiful day. I hope it is the same for you as well. Let me see. Okay. Today's topic covers primarily coastal processes and a little bit about the coastal protection options, how to select a coastal protection option for a site, a little bit about climate change as well. So I'll concentrate on science, which is problem solving. And your background is in engineering, which is practical problem solving. So we do need both science and engineering to solve coastal problem. And please note that coastal engineering is different from civil engineering, because we are going to deal with the dynamic environment. My understanding is that most of your background is non-coastal. So I suggest you to read some of these manuals, Coastal Engineering Manual by US Army Corps of Engineers, which is a Bible of Coastal Engineering, which is available online. Anyone can download this manual from the web. It's a freely downloadable version, and it covers the design criteria, coastal processes, material selection, so many things. I would strongly recommend to read this manual. Second thing is the ROC manual, which is by the Construction Industry and Research Information Association, or CIRIA, which is a Europe-based organization. That's also really good. And then PIANG has developed a state-of-the-art designing and construction of berm breakwaters. They are related to port and port breakwaters. We published another reference manual on climate change adaptation guidelines for coastal protection and management in India, which was supported by Asian Development Bank, and the executing agency for this project was the Ministry of Water Resources. Presently, it is the Ministry of Jal Shakti. Then NIO Goa, National Institute of Oceanography Goa, published another document, Guidelines for Protection and Control of Coastal Erosion in India, which is also a very relevant one. Then you might have heard about this IPCC reports, and recently they published in August, they published Climate Change 2021, the physical science basis. So all those things are really good background reading if you are interested to know more about coast and coastal processes. And climate change adaptation guidelines, which is in 2 volumes. The first volume is about the climate change and how to utilize the guidelines for coastal protection, how to utilize the guidelines, and what must be done to adapt climate change. And the volume 2, very detailed one, coastal processes, how to prepare a DPR, and the design criteria for sand-based solutions, which I will explain later, and seawater groins and offshore reefs, environmental impact assessment, and so many things are there. It is also available on the web, on the ministry's web or CPDAC, Coastal Protection Development Advisory Committee of Government of India, and even Irrigation Department's website also has this manual readily available. So in my talk, I will concentrate on the coastal area. This is a cross-shore profile of the coast. This is the landward part on your right side, and the coastal hinterland and dunes, which is simply a mound of sand, and the beach area there, and the water area. So I'll be concentrating mainly in the beach and the offshore area. Here, there's a term called depth of closure. This is also really important. And mean high water, mean sea level, mean low water. I'll explain some of these terms later in the presentation. So, can you see my full screen? I think, are you okay to see everything, or is any black?
Yes, no, okay. So we can see.
Okay. Okay. The first thing about the beach, people always think the beach is the dry part or visible part of the beach area. It is not really. It consists of the dry and the wet part. The dry part is whatever you see here, and the wet part up to a breaker zone or beyond the breaker zone. Breaker zone here, the waves are breaking, which is called breaker zone, a low tide line there and high tide line, then shoreline, that's a hinterland. So most of the processes are in this area, which is really important for our coastal planning, whether it is coastal protection or other activities in the coastal area. So our key theme of this talk is coastal erosion. So what erosion means, the loss of beach material by wave action, tidal currents, littoral currents. I'll explain these parameters later, or due to some other activities. And protection works is management of this beach area and how to control the erosion. And in your term, you call anti-sea erosion or coastal protection measures. All are the same meaning or same thing. Okay. And beach system, which is very dynamic. Like I said, in your civil engineering, you are dealing with most of the static thing. Here it is a very dynamic things, changing in response to the prevailing wave and water level conditions. Water level due to various aspects I'll explain later. Then cycles of erosion and accretion or submergence due to water level or increase. natural part of the coastal behavior. Don't think that when there's water somewhere, it is eroding. Need not be the case. But in unstable beaches, there's a long-term erosion trends. We need to identify which beach is unstable and how to fix it or how to manage it. So the bottom photographs are from Workala. You might be knowing about Workala, which is 40 kilometers north of Trivandrum. Pre-monsoon, April, May months, it is very dry, a beach, something around 70, 80 meters wide beach there. If you go there, same place during monsoon time, water everywhere, you won't see any dry beach. But post-monsoon, like now, or September, October, again, you will see a dry beach. So here, there's no erosion. It is only water level increase due to monsoon and various other factors. Some of these factors I will explain in my talk. So the message I want to give you here, a small water level increase or submergence doesn't mean that the coast is eroding. It could be simply inundation or an increase in the water level. So how to select a coastal protection option for a site? First, we need to understand the system, how it works, then identify the cause of erosion. Once you know the cause of erosion, you treat for that. So the high priority is to understand the system. To understand the system, we do need to know the coastal processes, the motion of the waves, nearshore currents, which are capable of moving sand, movement of beach sediments. So we know the importance of beach for daily livelihood activities like fisheries, recreational things, social values, tourism, and infrastructure, ports and harbors, and our coastal roads. So our coastal area is economically important, socially, and environmentally. At the same time, it's a nature's resource, and preservation of beaches and protection of the coastal properties and infrastructure requires an understanding of the nearshore processes or coastal processes. I'll be dealing with the waves because our coast is a wave-dominated coast. And then tides, nearshore current, sediment transport, then sea level rise due to climate change. Why? Because coastal processes determine the response of the coastal waves and tides or the dynamics of that region. There are a myriad of physical processes in the sea, but we will concentrate only 2-3 things because I can't cover everything within this 2 hours time. Let us check these waves. How do ocean waves develop? It is energy in transition. So wind transfers energy to the sea surface. Then it forms that small ripples, small bumps, then grow to higher or longer and faster and a wave. When it is closer to the storm or generating area, it is really messy and called sea waves. When it's away from that generation area, it's called swell waves. Away, I means thousands of kilometers. And there's a spectrum of waves. We can compose each wave field into a spectrum, and wind, sea waves, which is within the generating area, and waves from different directions, different heights. It's partly messy area. Then clean swells when it is away from the generating area. So there are several methods to separate these 2 components. And in terms of cost, erosion is primarily due to the sea waves, and our accretion happens because of the swell waves. And we need to see from where these waves we are getting on our coast. In the deep water, where the wave length is less than half the wavelength or greater than half the water depth, then it is called deep water, where the wave orbital velocity only negligible influence on the seabed.
Sir,
When it
voice
reaches the
is
shallow,
breaking, sir. Excuse me, sir. The
Yep.
voice is breaking.
Oh, okay. Let me see if it is, I should close my video. That will help. Okay, I stop my video. Is it better now? Okay, I'm sorry about that, or maybe the network problem. Let me see how I can make it better. When the waves are in deep water, where the deep water in terms of coastal science means it is greater than half the wavelength, and there is no influence of the wave on the seabed. So if the wavelength is 200 meters or 250 meters or 100 to 150 meters water depth, there is no influence of the surface waves on the seabed. But when it enters into the intermediate water, where the wavelength is less than half the wavelength, the wave orbital velocity starts to feel the bottom. And the orbital velocity initially in deep water, it is in round orbital velocity, then changes to elliptical shape. And then when it enters the depth where it is L is less than L by 20, or near shore area, it becomes unstable and break. So depth has a major role in coastal processes. In determining a solution or understanding the processes, we need to have a really good understanding about the nearshore water depth. And from this figure, where in deep water, it is straight, and in shallow water, there's a forward movement. Orbital velocity is because of the frictional effect, bottom frictional effect. And in shallow water, where L by 20 is depth is less than L by 20, it is unstable and it will break. So if your intermediate water is coming closer to the shallow water, or the nearshore area is further deeper, larger waves can come closer to the shore. So remember, depth has a huge impact on the coastal processes, coastal erosion and accretion. And when waves enters shallow water, wave speed decreases and the length also decreases, our height increases, but the wave period won't change. The effect of that one, when the angle between the front and back side of the wave is less than 120 degrees, it will break. Approximately, you can take about 75% of the, 3-4% of the water depth wave should break, which means a 10-meter wave will break at 7.5 meter water depth. If your water depth in the near shore is 5 meters, 3 to 3.5 meter wave can come closer to that one. On the other hand, if your water depth is only 1 meter, and 1 to 1.25 meter wave will come. So the near shore water depth, or the deepening of the water near shore area, either due to your coastal structures or erosion or increase in the water level, all will have significant impact in the coastal area. When the waves break, it is not simply breaking. It is taking huge quantity of sand as well. It's suspending sand. Then it will determine where the sand should go. If the sand can settle immediately to the seabed, it will settle there. If it can keep in suspension, it will move along shore, offshore, or upwards, depending on the nature of the waves there. We'll see what will happen. There are several types of breakers depending on the nearshore depth. If it is very steep, we call it a surging breakers. If it's moderately steep, it's plunging breakers. And if it's very shallow water, it is a spilling breakers. When you go to the beach next time, see what type of breakers you're observing there. That's all about the basics about the wave characteristics. However, I would strongly recommend you to read some of the books to have some detailed understanding about the waves and wave characteristics. So where do we get the waves? There are 2-3 main sources. One is from the Southern Oceans, where south of South Africa, this region, this is Antarctica, South Africa, or India is here, Australia, New Zealand is here. So this entire area open.
Sir. Hello, sir. Joseph, sir.
Hello. Hello, sir. Joseph, sir. Hello.
സാറേ,
ഹലോ ജോസഫ് സാർ സൗണ്ട് കേൾക്കുന്നില്ല കേട്ടോ.
ഇല്ല സാറേ, ഇതായിപ്പോയി, എക്സിറ്റ് ആയിപ്പോയി, ഇപ്പൊ വരുമായിരിക്കും.
എക്സിറ്റ്. ഓക്കെ ശരി ശരി.
സജു സാറേ, സാറിന്റെ നെറ്റ് ഇഷ്യൂ ആണോ?
നെറ്റ് ഇഷ്യൂ ആ സാർ, എക്സിറ്റ് ആയിട്ട് ജോയിൻ ചെയ്തിട്ടില്ല. നോക്കാം, നമുക്ക് ട്രൈ ചെയ്യാനില്ല. സാർ കിട്ടുന്നില്ല, സാറിന്റെ ഫോണിലും കിട്ടുന്നില്ല.
ആ, ഓക്കെ ഓക്കെ. എക്സ്ക്യൂസ് മീ പാർട്ടിസിപ്പൻസ്. സാറിനെ നമുക്ക് കണക്ട് ചെയ്യാൻ പറ്റുന്നില്ല കേട്ടോ. സാറിന് എന്തോ നെറ്റ് ഇഷ്യൂ ആണോ എന്തോ, ഫോൺ വിളിച്ചിട്ടും അറ്റൻഡ് കിട്ടുന്നില്ല. അപ്പം നമുക്ക് ഇന്നലത്തെ 2 സെഷൻ, വളരെ ഗംഭീരമായിട്ടുള്ളൊരു 2 സെഷൻ നിങ്ങൾ ഇന്നലെ അറ്റൻഡ് ചെയ്തിരുന്നു. അപ്പോൾ സമയം പോരാന്നും കുറച്ചും കൂടെ എക്സ്പ്ലനേഷൻ വേണം എന്നും ഒക്കെ ഉള്ള കമൻറ്റുകൾ കേട്ടിരുന്നു. അപ്പം നമുക്ക് ഇന്നലെ അതിൻ്റെ ഇവാലുവേഷൻ നടത്താൻ പറ്റിയിട്ടുണ്ടായിരുന്നില്ല. അപ്പോൾ എന്തായാലും ഒരു 2-3 മിനിറ്റിനുള്ളിൽ നമ്മുടെ ചാറ്റ് ബോക്സിൽ ആ 2 സെഷൻ്റെയും ഇവാലുവേഷൻ്റെ ലിങ്ക് ഇടും. അപ്പം നിങ്ങൾ ഈ സമയം കൊണ്ട് അത് ഒന്ന് അറ്റൻഡ് ചെയ്യാൻ, സാറ് കയറി വെച്ചാൽ നമുക്ക് പെട്ടെന്ന് റീജോയിൻ ചെയ്യുന്ന രീതിയിൽ ആ ഇവാലുവേഷൻ ലിങ്ക് ഒന്ന് ആൻസർ ചെയ്യാൻ നോക്കൂ കേട്ടോ. എല്ലാവരും എത്തിയിട്ടുണ്ടായിരുന്നു ഇന്ന് ക്ലാസ്സിലേക്ക്? പാർട്ടിസിപ്പൻസ് എല്ലാവരും എത്തിയിരുന്നോ? നിങ്ങളുടെ ടീം മെമ്പേഴ്സിനെ എല്ലാം നിങ്ങൾക്ക് പരിചയം ഉണ്ടാവുമെന്ന് വിചാരിക്കുന്നു. സജു സാർ,
ആൾക്കാരുണ്ട്, നമുക്ക് ആ ലിങ്ക് അയച്ചു കൊടുക്കാം.
ആ ലിങ്ക് ചാറ്റ് ബോക്സിലോട്ട് ഇട്ടോളൂ സാറേ.
ഓക്കെ.
അപ്പൊ അവർക്ക് ആ ടൈം യൂട്ടിലൈസ് ചെയ്യാൻ പറ്റുമല്ലോ. സാറിന് എന്തെങ്കിലും നെറ്റ്വർക്ക് ഇഷ്യൂ ആയിരിക്കും.
ഇട്ടിട്ടുണ്ട്.
ഇന്നലത്തെ ബിബി സാറിന്റെ ക്ലാസ്സിന്റെ എക്സാം ചാറ്റ് ബോക്സ് ഇട്ടിട്ടുണ്ട്.
ലിങ്ക് ഷെയർ ചെയ്തിട്ടുണ്ട്. ഒന്ന് ചാറ്റ് ബോക്സ് ഒന്ന് നോക്കിക്കോളൂ.
ഇന്നത്തെ സെക്കൻഡ് ക്ലാസ് ആയ സുശീല മാഡത്തിന്റെ ക്ലാസ്സിന്റെ എക്സാമിന്റെ ലിങ്ക് ഇട്ടിട്ടുണ്ട്.
ഹലോ പാർട്ടിസിപ്പൻസ്, ജോസഫ് സാറിനെ വിളിച്ചിട്ട് കിട്ടിയായിരുന്നു. അപ്പൊ സാർ ഉടനെ തന്നെ ജോയിൻ ചെയ്യുന്നതായിരിക്കും. സാറ് ഇത് ഇവിടുന്ന് ഡിസ്കണക്ട് ആയത് അറിയാതെ സാർ ക്ലാസ് എടുത്തുകൊണ്ടിരിക്കുകയായിരുന്നു. അപ്പൊ ഞാനിപ്പോ വിളിച്ചപ്പോ ഉടനെ തന്നെ റീജോയിൻ ചെയ്യാമെന്ന് പറഞ്ഞിട്ടുണ്ട് കേട്ടോ.
Sorry about that one. Okay, let me share my screen again. Can you see my slide here?
Yes, sir. Yes. Slide show it all, sir. Slide show it all, sir. Okay, sir. Okay.
Yeah, I'm really sorry about that. അപ്പൊ ഞാനിപ്പോ വേറെ നെറ്റിലേക്ക് ആക്കി, നേരത്തെ നെറ്റ് പോയത് അറിഞ്ഞില്ല. എത്ര സ്ലൈഡ് ഇതൊക്കെ കണ്ടിരുന്നോ? കണ്ടിരുന്നു. ഓക്കെ, അപ്പൊ ഞാൻ മുന്നോട്ട് പോകുന്നു. ഏത് കാണാൻ ഇത് കണ്ടിരുന്നല്ലോ? ഞാൻ എവിടം വരെ പറഞ്ഞു എന്നുള്ളത് എനിക്ക് അറിയത്തില്ലാത്തതുകൊണ്ട് ഞാൻ ചോദിക്കുകയാണ്. അല്ലെങ്കിൽ ഞാൻ ഒന്നുകൂടെ ഒന്ന് റിപ്പീറ്റ് ചെയ്ത് പോകാം പെട്ടെന്ന്. Okay. So I'm really sorry about that one. So yeah, what I said earlier was the importance of coastal environment for our livelihood activities, industries, recreational, social, and environmental things. So we do need to know about the coastal process, the motion of the waves, nearshore currents, sediment movement, and variability in the wave shape. So preservation of the beaches is really important. To do that one, we need to have a good understanding about the coastal processes, which includes waves, tides, nearshore currents, sediment transport, because these forces are determining the shape of our coast, and primarily waves and currents. So I'll concentrate more on the waves. I'm going a little bit faster here, otherwise I won't be able to finish this one. However, I strongly recommend you to read the manuals I suggested earlier. And waves are energy in transition. When a wind blows, it and bump forms there, then slowly into the waves. And waves in the generating areas are called sea waves. And generating area is determined by the force of the wind, or if it is cyclonic thing, it's a huge area, thousands of kilometers. And once it is outside that generating area, it is called swell waves, long period and long swells. And in the generating area, sea waves, it's from different directions. And if you divide into a spectrum, you can have wind waves of a particular period, energy concentrating in that particular area, then swell waves as well. And then many situations we get both combined swells and seas, like what we get on the west coast of India. I'll show you that one in a minute. The most important parameter for us is the relationship between the water depth and waves. In deep water is defined as more than half the wavelength. If wavelength is 250 meters, deep water is defined as 100 meters. And when it enters the shallow water or intermediate water, it starts to feel the bottom. Then sediment movement, all those processes, whether it is a resuspension in some cases it is actually transport, depending on the currents of that region. And the nearshore area, what would happen is wavelength decreases and period remains the same, height increases, and waves become unstable and break. So we need to determine where is this breaker zone. And this is the definition of what is deep water transition zone and shallow water, purely depend on the wavelength. So in shallow water, really important, and the wave speed decreases because of the frictional effects, and wavelength decreases. If it was 200, 240 meters, it can decrease to 30, 40 meters when it reaches near shore area. And wave period won't change, but height increases. It cannot increase for a long thing. It will become unstable, and the instability will happen when it reaches the wave height is greater than 1/7 of the wavelength, or approximately 3/4 of the water depth. What does it mean? That a 10-meter wave will break around 7.5-meter water depth. It won't come closer to the beach. And at the same time, if your near shore is 5 meters, 3 to 4 meters high waves can come. So there's a direct relationship between water depth and the wave height and where the wave should break. And when it breaks, if it is sandy bed, it takes a lot of sand from the seabed, keep it in suspension. If the sand is capable of keeping there, depending on the density, it will be there floating for a little while, and the next wave or current will determine where the sand should go. We'll see the impact of that one later. At the same time, if the sediment is denser, it will fall immediately. So many processes. The wave breaking is not just water alone. It takes sand as well, huge quantity of sand. There are different types of breakers depending on the beach steepness. If it's a very steep beach, it's called surging breakers. And if it is a steep beach, or plunging breakers, the shape of that one, plunging one. And if it is intermediate or horizontal beach or low gradient beach, it's called spilling breakers. And our coast, Kerala coast, experiences this type of waves. Particularly in Trivandrum, we are getting plunging breakers, which is really steep, and Cochin and some of the northern parts, we get spilling breakers. So different types of waves. And from where do we get the waves? And two main sources and the third source. And the two main sources are, one is from the Southern Ocean. We know this is India here, and open North Indian Ocean, South Indian Ocean, Antarctic region. And always here, it's called roaring 40s. And westerly winds throughout the year in this region. This is very open, except South America and a little bit of Australia, Tasmania and New Zealand. All others are open ocean and free area. Always storms form here. And that storms generate waves, and we get that waves propagate to the north, and we get waves here throughout the year. And however, during monsoon time, we get waves from the Horn of Africa, and this is within the generating area. And the previous one is outside the generating area. We get swell waves, which is long period swells. And these are short period waves and the sea waves. We get another waves sometime in the year, particularly from December to May, northeast, called Shamal waves from the Oman region. It is really important for Maharashtra and north of Karnataka, but little effect on our coast as well. And now, because of the climate change, we get one more type of waves, which is cyclone-induced waves. It can be from any direction. So previously, we had a predictability there in terms of from where we are going to get the waves. Now it has changed. So that is the importance of climate change and coastal planning. If you take the overall picture of the globe, this is what I said, South Africa and Antarctic region, and storms and westerly winds throughout the year, only westerly winds. And sometimes, and during this time, the Southern Ocean is very energetic because it is the winter time, very energetic there. At the same time, even though it is summertime in Northern Hemisphere, monsoon is here. So which is a very unique phenomena of our region, and storm waves form here. So we get monsoon waves as well as the southern waves. However, monsoon waves mask the effect of the waves from the southern ocean waves. And when the monsoon waves or monsoon is weak, and if there's a storm there, we get waves from the south as well. For waves, we need to consider a particular parameter. Normally, we take a spectrum based on a long period measurement and take maximum waves and highest 10% waves and 1/3 and mean median. But most of the design, we take significant wave height or HS, which is the average of the highest 1/3 waves. In some cases, we do need to get or consider the maximum wave height as well, and particularly wave overtopping, and in some case of coastal, very important coastal structures, we need to consider the maximum wave height. Here, this for a long period from 2005 to 2019. This is significant wave height, not maximum. And the relationship between significant wave height and maximum wave height is about 1.75 times the significant wave height is maximum wave height. You can take even double. So what does it mean? A 3-meter high waves is actually 5 to 6 meters in the offshore. We may be seeing only 3 or 4 meters, but in the offshore, it is 3 to 4 meters or 4 to 5 meters. When you take a longer period wave climate, the top one is wave height or the significant wave height, and second one is a wave period. This period is a peak period, which is a maximum energy period. There are different wave periods, mean, zero crossing, so many parameters are there, but this is a peak period. Why? It's a maximum wave energy is there, and then peak direction, which is maximum wave direction. If you take for a longer period, we get calm periods and high energy periods alternatively. And this is 1st of January 2005, we get low energy period, then a period of high energy for 3 to 4 months, that is monsoon period, low energy period, high energy period, and the wave height changes. And it's a very predictable. In between, we get episodic events. So this is an event in 2007, June, which also has some impact on our coast, depending on the wave direction. And the direction also changes periodically or seasonally. When we get monsoon waves, the waves are from about 270 westerly quadrant. And the non-monsoon period or the dry period, waves are from the south. And the Shamal waves are from the 315 degrees, which is from the northwest direction. Not dominant, but we do get that one. And the period also, we get long period swells, about 15 to 20 seconds from the south, and monsoon waves about 9 to 10 seconds, and Shamal in the lower 5 to 7 second periods. So for coastal protection design, or to understand the coastal process, we must have information about wave height, wave period, and wave direction. If you take a shorter period, or 1 year thing, and from January to May, we get waves less than a meter. Of course, this is significant wave height, not maximum wave height, average of the 1/3 highest wave heights. And in May, we get more than a meter or closer to a meter. And during December, January, and March, other times, we get less than a meter or calm conditions. When we get these calm periods, or wave periods are also longer, 15 to 20 seconds here. You can see that when wave periods are longer. But when during monsoon time, we get the heights of more than 3 meters. And more importantly, waves are consistently more than a meter throughout 3 to 4 months, which is a very unique phenomena of the west coast of India. And I'll show you other coasts as well. And post-monsoon, we get really good long period swells from the south, which is from that 200 to 220 degrees southwesterly directions. So the wave climate of our coast is very predictable, long period swells from the south, monsoon waves, higher waves from the west quadrant, and about 270 degrees, and wave period about 9 to 10 seconds. But during monsoon time also we get a longer period swells. If monsoon is here, when the monsoon was really weak, the longer period swells from the south also came. So I'm going to tell how this is going to affect our erosion accretion process, particularly these post-monsoon things, when the waves are about 1 meter, long period swells, waves coming from the south, and when waves coming from the west, and wave period is about 8 to 9 seconds or 10 seconds, and higher waves, how erosion accretion is going to happen. If you seasonally, if you take that one, monsoon season, higher waves coming from the west, we do get westerly cotton waves, sorry, southwesterly as well. And wave period, you can see that one, shorter period, 9 to 10 seconds period. But the long period swells from the south is also evident there during monsoon time. And during non-monsoon time, the waves are and longer period from the south. Is it my, its internet is unstable. Can you hear me? Is it okay?
Voice is breaking. Sometimes
Okay,
it's
okay,
breaking.
thank you. So this is a seasonal thing. And if you take a monthly thing, January we are getting primarily from the southwest, little bit component from the northeast, and February primarily from the southwest, March northeast plus southwest, April primarily from the southwest, and May little bit of westerly component as well, and June westerly, and July mainly westerly, August westerly weakened, but southwesterly started that one, and September further weakening of the westerly, southwesterly strengthening, and October mainly southwesterly, a little bit of westerly there, and November also there, and December small northwesterly, northeasterly, and southwesterly. This is the general characteristic or wave climate of our coast if you take for an year. And if we do have forecast available, we do, this is freely available, software available on the web. And this is the forecast for KERI, about 12 kilometers north of Ernakulam, 20 kilometers north of Ernakulam. And the top one is a wave height on the 24th, this I took yesterday. Yesterday it was about 1.2 to 0.8 meter wave height. And we know that on next few days, we are going to get some peaks, 27, 28, then calm periods. Then towards the end of this month, we are going to get another small storm about 2 meters. To first week of September, about 1.7 to 1.6 meters. So not too bad. And if you take, this is for 2 weeks forecast, and hourly or 3 hourly for every day, that's also available. And for Saturday, 28th of September, starting from midnight, and waves about 2 meters, and coming from the westerly quadrant, 7 to 8 second period waves. And same time, there's a secondary waves coming from the southwest of 15 to 16 seconds period. Then one more swell of 20 seconds, that's also coming from the south. So if you take an instantaneous thing, I took today at lunchtime for KERI, waves were primarily from the southwest. And I know that today's tide was 0.82 meters at early morning, and the next high tide is 0.86 meters around, it was at 1:27 p.m., 1:30 p.m., and the lower tide 0.14 meters. So most of the information readily available now. There's no dearth of information. Only thing is that we need to utilize this information in our planning, not only for cost of protection. So if you want to know when we are going to get the next long period swells from the south, and this is for the 30th August, what is going to happen in a global scale, when a storm passes South Africa, we get waves, some of it propagates to the northern Indian Ocean as well, and we get long period swells. And this storm, which forms around the 30th of August, which is about 25 days from now, and reaches here on our coast around the 4th of September. But the wave height about a meter, and here you can see that when this color is about 30 foot and a 10-meter wave, and this wave about 40 foot, which is about 13, 14 meters high. So huge waves form there because really high energy. Southern Ocean is really, really energetic now because of the winter season. This is Australia here, New Zealand here, then Indonesia. That's why this is a wave period. Surfing is very popular in these countries. This is Perth in Australia and New Zealand, east coast of New Zealand, really popular surfing destinations, and Indonesia, Bali and other areas, highly important tourist destination, primarily due to surfing because of waves come this Southern Ocean, and that's particularly long period swells really ideal for surfing. Unfortunately for India, we have this Maldives, which is blocking some of these long period swells, and Sri Lanka, it is causing some impact on the east coast. Otherwise, our South India would have been a really, really good surfing destination. Still, we get some good swells for beach development. And in terms of coastal planning, we do need much more than daily or yearly thing. We do need long period wave climate. This is 13.5 years of a wave climate. Wave height against the wave directions, and bigger waves, 5 to 6 meters waves, are coming from the westerly quadrant. And from the southerly quadrant, we are getting waves less than 2 meters. And from the northwesterly quadrant, it is less than around 1 meter. These are all offshore wave climate. Since it is offshore, we needed to calibrate it by measured waves in the near shore. So we actually calibrated this data, and this is during monsoon time wave height calibration. We got a really good calibration, and now we do have the confidence in using satellite data for our coastal planning. 30, 40 years of data available now from various agencies. So previously, people use ship observed data for coastal planning or coastal protection design, which is not really accurate based on the observation of that particular period and based on the accuracy of that observation. However, we do have much better data available now and for longer period, 30, 40 years. And why our coast is unique compared to other coasts of the world? I compared this one with the west coast of India, that's Mangalore wave climate, representing the west coast, then east coast Chennai wave climate, and southern hemisphere, Gold Coast, Australia, and northern hemisphere, California. If you compare that one, only we get long monsoon periods, 3 to 4 months, and long dry periods. On the other hand, on the East Coast, they get waves about 1 meter throughout the year, except during their monsoon, which is northeast monsoon from October to January. And southern hemisphere, every fortnight or 3 weeks, they get a peak, then come period. So approach of coastal protection and coastal management for the subtropics and our region is totally different. We do need to have good understanding of the monsoon dynamics. When you read books, you get really good information about coastal processes, but remember, and our environment is totally different. We apply a technology for monsoon dynamics. It is a very unique and entirely different from other areas, even different from the west coast, east coast of India. The Wales here is that we get two tides, two high tides, two low tides every day here, and which determines the littoral zone and huge impact on our planning. And the tide is different at different locations. And in Kerala and Trivandrum, it's about a meter. And when you go to North Kerala, it's about 1.5, which is tidal range from low tide to high tide, or spring tidal range. And if you go to Gujarat, you can get up to 12 meters. And Mumbai, it is 5 meters. So that's why in Gujarat, there are intertidal area, which is the area between high tide and low tide, several kilometers. And our intertidal areas, nearly zero or only a few meters, which means bigger waves can come closer to our coast throughout the year. And tide is very predictable because it is depending on the attraction of the sun and moon, and we can predict for any hundreds of years at for any point. It varies a little bit, and this is for tidal prediction for 1 year for Cochin. It's about a meter vary, and mean sea level there, it's about a 0.58 meters, and spring tidal range is about a meter. Note that tide is not starting from zero, a term we call datum. I'll explain in the next slide. So when the sun and moon are aligned with the earth, we get maximum tide, which is called spring tide. And when the sun, moon, and earth are at an angle, we call lesser or the lower water level, it's called neap tide. So we get spring tide for a few days, then neap tide and the spring tide, depending on the movement of the rotation of the earth and the moon. So the tide is not constant throughout the day or throughout the month. Really important for us to remember, chart datum, which is normally taken as the lowest astronomical tide, need not be the low tide level. It can be the lowest astronomical tide measured over a period of 19 years, and which is always taken as zero. So when we talk about zero for Cochin, it is zero for the lowest astronomical tide. And 5 meter water depth in the near shore means 5 meter below this zero. And the maximum wave can be 6 meters here, 5 meter plus 1 meter tide. On the other hand, if we take Kasaragod, 5 meter tide, and at spring high tide, it is 6.5 meters. So chart datum is really, really important to understand. And most of the time, it is lowest astronomical tide. This is some information about Cochin. Highest high water level is plus 1.2 meters. Remember, lowest to low water is 0.2 meters. So their highest high, and the mean sea level is 0.58 meters. In terms of construction, you should have a really good understanding about where is your mean high water. Means where is that height, and during a high tide, your water level in that area, what will be the maximum height in that particular area. So please have some information about this datum and selection of that one. And next is currents. There are several currents there. I'm going to talk only about littoral currents or longshore currents, which is primarily driven by waves. So that's really important for our coastal planning or coastal protection. How the longshore currents are formed. When the waves approach the coast at an angle, it breaks and form a current, which is called longshore current. And our coast, this is Trivandrum coast, and the angle is 320 against, if you take the true north, and the true shore normal is 230. And when the waves coming from the 230, it is shore normal. But if the wave is approaching at 240 or 220, it is at an angle. It can create a current and move sediment according to that direction. And during monsoon time, waves are coming from the westerly quadrant, And our shore normal is 230 degrees. And even if waves coming 250 or 250 or 270, and the current in the southerly direction can create a form, and which can move sediment in this to the southerly direction. So this is really important for planning of coastal structures, longshore sediment transport, which is a function of the angle of wave approach and wave energy. Unfortunately, during monsoon time, we get maximum wave energy, and waves break further offshore, and which is called surf zone, wave breaking zone. And sediment can be resuspended, enter this area. This can be several tens of meters, 60, 70 to 100 meters, depending on the depth, near shore water depth. And during non-monsoon time, waves break very close to the shore, and the surf zone is very narrow, and sediment transport happens primarily in this area. Okay. And from where do we get sediments? Different sources, hinterlands, rivers, volcanoes, corals. But for us, we need to consider only rivers. Rivers actually supplying new sand to the coastal system. And if there is depletion in the river sand, then it will affect our coast as well. Near shore area, when the sand reaches, it will move along shore or offshore, cross shore direction, depending on the situation. So this is called longshore sediment transport. And if there's a dam constructed there, the dam blocks sediment there, and we get only very limited sediments, which sand mining there, that is also depleting the sand resources to the beach. If you construct a harbor, a port there, and of course, sand accumulation in the harbor, and we do dredging and take the sand to offshore or in the near shore sand land filling, that also depleting the sand for the beach area. If we have a coastal structure perpendicular to the thing, that will also affect the longshore sediment transport, and it can create accretion or erosion. So anything in the coastal area, including sediment supply from the rivers or sand mining or river dam construction, all have some impact in the coastal erosion. This is an example from Mudalappally, Trivandrum area. A 550-meter breakwater is called breakwater for safe navigation, which accumulated quite a lot of sand here in the southern area and huge erosion. We should have a really good understanding about the longshore sediment transport. Next one is if the sand moves north or south, from how far it can move, it is called sediment cell. It is divided into primary, secondary, and tertiary. The main concept is very little sediment exchange between the cells, depending on the seasonal thing, because we are getting waves from different directions. And secondary cells are a few kilometers and divided by either by headlands or coastal structures, or tertiary cells based on port structures. So whatever we do in a sediment cell, that will have an impact in the entire sediment cell. If it's a primary cell, impact will be over a longer period, secondary cell, medium term, and tertiary cell, it will be immediate impact. And we do need to identify when we are doing a coastal structure or any activity in a coastal region, where is our sediment cell, primary cell, secondary cell, tertiary cell, and impact within the entire cell, not at that particular location. And NCSCM in Chennai have developed sediment cells for entire India. For Kerala, only 2 primary cells, which means if we do anything within that cell, will have impact on the entire Kerala coast, and only 5 subcells. Now we do have one more thing, climate change. And our coast is really prone to erosion. In addition to that one, we are going to get more frequent severe cyclones and flooding of the low-lying areas and coastal erosion. And in our coastal planning, we decided 1 in 100-year coastal events, like episodic events. That is why I suggested 13, 14 years of data. We collect wave data, and using statistical methods, we go for a 1 in 100-year event. But that 1 in 100-year event is going to happen yearly now. So there should be some change in our coastal planning. And young engineers are totally in a different environment now. We need to think differently from the traditional coastal management and coastal protection method, because got a lot of uncertainties with the climate change. And previously we had the predictability that has gone now. So we need to plan for unpredictable things as well. There are measured evidence there, and temperature is going up almost 1.25 or closer to 1.5 now. And sea level is definitely going to rise. And under different scenarios, definitely 0.5 to 1 meter sea level rise by 2100 is a very, very likely scenario. We did a study, which is available in that manual on climate change adaptation guidelines for India. And we estimated about a meter sea level rise along the Kerala coast and up to 38 centimeters by 2050, about a meter by 2100, depending on the ice melting and temperature increase. However, these are reasonable estimates. Now we are getting frequent cyclones. If we take 18, 19, 20, 21, 18 we had some cyclones, and 19 we had on Arabian Sea, means Arabian Sea, about 5 cyclones, and from different directions, different periods. And in 2021, we already have 1 cyclone, Cyclone Taute, which means that we can expect more in the coming years. And our wave directions definitely changed. When the cyclone moving from the south to north, we get waves from south to north. And when the cyclone is in the north, we can get waves from the north. Our predictability has gone. More importantly, these cyclones occur either just before the monsoon, like Cyclone Taute in May, or towards the end of the monsoon or in the post-monsoon. Both are really, really dangerous for us, particularly for our coast. That's why I showed the uniqueness of our coast. 4 months of high wave activity, then dry period with the low wave activity, which is a beach rebuilding period. And cyclones, not only the waves, it increases the water level, called storm surge. 1 millibar decrease in the drop in the pressure means 1 centimeter increase in the water level. Our average atmospheric pressure is 1013. During monsoon time, we get about 1010. And Cyclone Taute, and this is for Kochi, we got drop was less than 995, about 14-15 centimeter difference or pressure drop, which means that 15 centimeter increase in the water level. And we all know the impact of that small increase in the water level on our coast. Not only the storm surge, and there's another effect called wind setup, which I'll explain later. So the storm surge in the climate change conditions, we can expect for Kerala 1 to 2 meters. If there's an increase of 1 to 2 meters water level, near shore water level, and the depth increases, then higher waves can come. Inundation is one problem. Second thing is that coastal erosion will be really, really severe. And Kerala is going to suffer significantly under climate change unless we do our planning properly. What are the causes of erosion? Natural process, human activities, and natural and human activities like long-term sea level rise or land subsidence. Human activities are construction of port breakwaters or removal of sediment from the coastal system, and reduction in sediment supply like dredging of navigational channels or dams or rivers and mining. Natural process. So let us concentrate in the beach system area, not in the deep water. What is happening in this area? When the waves come, if it is a short period stormy waves, it can break, bigger waves can break, and a water level increase in the nearshore area, and a gradient generates in the offshore direction that creates a current towards offshore. Waves suspend sediments, and that small current can move sediment offshore. And that will go offshore depending on the surf zone width and how big the waves are. If you allow your near shore to deepen, then bigger waves can come, break there, stronger currents can occur, and bigger erosion. This is why there's a direct relation between coastal erosion and water depth. If our near shore is deeper, larger waves can come, take sand offshore, and where it goes up to offshore, which is also really important. Under normal conditions, it may go up to a depth called depth of closure, which I explained earlier. For our coast, maximum 10 meters. If it goes beyond 10 meters, whether we will get that sand back to the beach. This is something we need to consider under climate change. So bed return flow is the main cause of erosion during stormy events or monsoon. So we get 3 to 4 months of monsoon, unlike a week or 2 weeks in the subtropics. So very waves from the Southern Ocean propagates to the north. This is actually Mahi port. The wave height increases and the flat crest, flat trough area and narrow crest, and this trough creates a strong onshore velocity and the asymmetry in the onshore direction, which creates beach rebuilding. That sand is suspended from the near shore when the waves enter in the sediment in the bed, and the orbital velocity can create an asymmetry. That asymmetry is in the onshore direction. That onshore wave asymmetry causes onshore movement of some conditions. The asymmetry is in the offshore direction. I hope you got the erosion accretion normal condition. So storm conditions, storm massive waves break, and swash is less in the onshore direction, more in the offshore, or strong backwash takes sand in the offshore direction. And offshore, it deposits where it is called an offshore bar, the sediment deposited there. During non-monsoon, strong onshore movement, and sand is moved in the onshore direction, and it helps beach building. And the height of that beach berm depends on the tidal conditions. So we get very small, about a 2 meter or 2.5 meter beach level because our tide is only a meter. And when you go to the north, maybe 2.5, 3 meters. So the clean swells are helpful for beach building, and storm cells definitely causing erosion. So what is happening generally under normal conditions, beach building, and under storm conditions, the sand reserve is there called dunes, and taking it offshore and form an offshore bar. And there's no erosion. It is only lowering of the profile is happening here. Actually, not erosion. Taking it offshore and bringing it not lost from the system. Of course, longshore transport will remove sediments, and we will discuss that. And this is a seasonal phenomenon. That is why the importance of the beach. Beach serves as a natural buffer between the ocean and the sand. And sand, these dunes are available for the storms to come and take the sand. And the offshore bar is actually helping, or nature's way of helping the beaches by breaking bigger waves there. Because water depth decreases and the higher waves break there. So impact on the beach will be less. So it is the nature's way of protecting the beach. And under normal circumstances, it's only a redistribution of sediment from the zone A, which is the dune area. And surf zone determines where the sand should go, and either it goes offshore, then the longer period waves will come. It's only a redistribution. However, there's a second type of erosion called coastline erosion, primarily due to coastal structures. When we construct structures perpendicular to the coast, which interrupts sediment transport, and supply of sediment to the down-drip coast are less, which will erode to reach an equilibrium. This erosion is a long-term erosion. The monsoon or storm erosion is seasonal and short-term. However, this is long-term erosion. Some examples of groins, groins are short perpendicular structures. So this is from Pollur, Kerala, Tamil Nadu border, which block the sediments in the south, immediately the north. Long 200 meters breakwater constructed in Chethi near Arabi. And so if the coast is drift aligned, or when the longshore transport is strong, common cause of erosion is lack of sediment supply. It can be due to structures or due to natural processes. And sometimes we get both longshore and cross-shore erosion. This is typical of some of our coasts. And most storm waves can take sand to offshore, and longshore sediments can take it further alongshore, which is also happening particularly in southern Kerala coast. One more thing called end erosion of seawalls. And if we construct a seawall, if we end somewhere, energy cannot stop there, which will further move and take sand, and excess energy is being transferred to the coast, and end erosion, and which is a net landward movement of the coast. There are several examples along the Kerala coast recently, particularly during Cyclone Tauktae. This is the importance of the wave directions. We never expected higher waves from the northeast. Our seawall stopped there, however, because of the end effect, huge erosion, end effect, Calicut, and I think this is Pollur area. And the end effect is huge, several hundreds of meters. A small structural intervention is required to create such end effect. So something you need to monitor during your career is whether we stopped at seawall somewhere, and the earlier northeast waves are not really strong, but the monsoon waves really going to cause this problem. One more thing is happening now is a wave overtopping due to various reasons. Either our seawalls too low, or our land is too low compared to the nearshore area, which is a totally different process. Inundation and wave overtopping is different from coastal erosion. And many people complained about coastal erosion, entire Kerala coast during Cyclone Taute. But in my observation, erosion happened only in certain areas. Most of the areas, it is inundation or wave overtopping because our coastal structures are too strong. And to determine the wave overtopping, we need to know the height of the structure or the so many parameters, which I'll explain in my next slide. So during cyclones, waves, depending on the near shore depth, bigger waves can come and break there. And if the tide is high tide, this spring tide, and even 20, 30 centimeters of storm surge can cause bigger inundation or wave overtopping. And in a coastal design, you need to consider water levels due to various parameters, tides, coastal currents and Coriolis force, cyclones, barometric pressure, sea level rise, and quite a lot of parameters. Of course, these are available in that engineering manual, not just the waves. So the summary of this one is we do need more scientific studies for coastal management. It's already complex with the various phenomena, and under climate change, it is going to be different. So we do need to consider entire sediment cell when we plan our coastal protection or coastal management, other than piecemeal approaches. So most of the cases, we have been considering only one formula called Hudson formula. You will hear about that one later, and which determines only the size of the armor block, and one formula and one design, which may not be suitable for the entire area. We should have a better approach for coastal zone management. We should understand the system, and desktop studies, modeling studies, design studies, implementation, and post-construction monitoring. And we should follow that process. And data collection is a very important part of that one. The data includes bathymetry, wind, sea level, currents, waves. All those parameters are really important for our coastal design. Sediment dynamics, longshore sediment transport, the shape of the beach, sediment grain size, river flow, and water parameters, beach and dune vegetation. And with increasing uncertainty in the climate change, we should have reliable coastal information. And monitoring, and KERI has been doing this beach profile monitoring. From that monitoring, this is beach profile monitoring, we should get a really good idea about the erosion of the coast. This is beach profile monitoring from 2017 to 18 from Mangalore. And within that short period, so beach width during summertime, about 70 to 80 meter. And next year, we noticed that one, it's reduced to less than 70 meters, 65 meters, a 10-meter erosion of the beach within a very short time. Not only the length, the height also decreased, which is really, really important. When we consider that one, not only the near shore area, we should consider up to depth of closure if possible. Then only we will know what is happening in the near shore area. This is from Trivandrum. During Cyclone Oki, beach profile has lowered significantly. The profile was about 3 to 4 meters during some monsoon time, and pre-monsoon time we redeveloped, and that is this yellow color. However, sorry, what is that? December red color is November 17 is this one. And after the Cyclone Oki, lowered significantly, but post-monsoon, the beach could not recover fully. And this is another better close-up of that one. An offshore bar formed, but the next monsoon, non-monsoon waves are not really strong to rebuild that beach, which resulted in significant erosion of that coast, and which is continuing. Bathymetry, you will be collecting that one for modeling or your planning purpose. Please remember, the near shore area is really, really important for your planning. However, what I noticed from here, huge data gap in the near shore area. Unless you know what is the water depth in that area, you won't know, or you can't study the coastal or the coastal process or the dynamics. So please make sure that you get really good data coverage for the entire area. 3 to 4 meters, not really important because the boats can come only up to that meter. There are methods to do nearshore survey. Please ensure that when you get full coverage of the data. When you measure currents, that's also really important. If you deploy your current meter closer to rocks and all those things, you get totally messy currents. Make sure that your deployment location is very important. And remember, we are using electromagnetic current meters, and it should be away from all the magnetic stuff. Otherwise, your compass will be affected, and that will affect your current direction. You won't get the reliable data. And nowadays, we use acoustic Doppler current profiles, which is different layers, really good. However, what we are interested in sediment transport is near bottom currents. People give you current velocities. So surface currents may be totally different direction, which is due to wind effect. The mid-level also can be different, especially due to monsoon waves or fresh water. But the bottom current is something which is going to determine the sediment transport. So when someone gives you the current data, please ensure it is near bottom, closer to the bottom. If they give surface currents, useless. It may be 3 meters, 4 meters, but what we need to know the strength of the nearshore currents. Likewise, wind is also really important, which is available readily. And normally 10 meters above the seabed means sea level is the wind that we need to use. However, it is free from structures. There should not be any impact of the buildings or forest or anything. It should be free of such things. Sediment grain size is really important. So there's a direct relationship between sediment grain size and beach slope. Higher the sediment size, steeper the slope. And the low sediment size means low gradient beach. And the median grain sizes, we need to find the distribution and take the median grain size. And these are really good for using numerical modeling tools and waves, currents, and any scenario you can plan. And this is for a reef design, which direction the currents moves, waves and orbital velocities and shadow zones, and beach development, how long it will take. This is morphological modeling. 2 structures are there, first year, second year, third year. Even after 5 meters, we know how far the beach building is happening. Techniques are available now to do that one. So I got only very little time now, maybe another 10 or 15 minutes. I need to rush through these options. And these are all about coastal process. I'm sorry I couldn't explain in detail, but I strongly recommend go through that manual. So the options are, one is do nothing, which is very practical in some cases, and manage realignment or relocation, or hold the line like sea walls or are there. And if low economic activity or high economic activity and higher the cost of protecting some regions, definitely relocation should be considered. However, protection methods using structural things, there are several hard engineering, soft, hybrid, and nature-based. And the functions of these things readily available in the coastal engineering manual, and please read those manuals for each structure, how it performs. Very detailed things are there. However, in the coastal protection manual, climate change adaptation manual, we give another table with the coastal protection, soft, moderate, hard, in terms of environmental impact. We call soft solution with the minimum environmental impact, moderate or hard solutions. So it depends on what you want to protect. If you want to protect the coast or the land behind it, you may need to go for hard structures. But if you want to protect the coast, like the beach area, your beach is dry and wet, you may need to go for soft or hybrid solutions. And if it is low-lying areas or flooding inundation areas, you can use soft or nature-based solutions. And restored wetlands or mangroves can give some sort of resilience for low-lying areas. However, remember, for open coast, it may not be applicable. And in low erosion and low exposed areas, such nature-based solutions are applicable. People talk about mangrove planting and vegetation in other cost protection measures, but remember, only for low-lying and low energy. The Kerala coast some areas, however, mainly for sheltered areas, not on open coast. And restoration, there are so many things to consider. I understand that there will be a separate session on mangroves, so I won't explain in detail. So low gradient beaches, especially in northern Kerala, some places beach may not be eroding, it is only water level increase. So you may not need hard structures like sea walls there. There are other methods which we can use. If you use sea walls, you use natural solutions and or nature-based, and wave runoff, it will act very naturally. And we call sand-based coastal protection measures, which are dune care, beach nourishment, beach recycling or reprofiling, and sand bypassing and bypassing. And it's only dune planting, and there are certain conditions of that. And we do need a wide beach even during high tide conditions. And dune nourishment protect the beach and or the entire beach called beach nourishment. So let us see some of those things. Dune care, just only planting, no sand movement or bringing her in sand, just to keep the sand there, nothing more than that one. And planting is very essential. At the same time, fencing is also really important to minimize any damage to the dunes. But on an eroding coast, dune care won't apply. We need to go for some other solutions like dune nourishment. Two methods of doing that one: taking sand from the lower part of the beach, which is below low tide area, put in the upper part, create a dune, provided you get a wide beach in between. Don't do very close to low tide area, it will erode immediately. Or you can bring new sand from outside source and nourish that beach if sand is not available. This is a method of doing that one. A dry, wide beach, sand taken from the low tide part, created a dune here, and next monsoon in 2020 July, waves reached only up to that level, which prevented flooding of the hinterland. And post-monsoon, still it was active, okay, and natural growth happened. And even during Cyclone Taute, it provided good protection, provided you should have a wide beach. And there are certain parameters for the design. That's why I said there should be a wide, dry beach between the high tide line and the dune. Otherwise, it will erode immediately. Then beach nourishment, bringing sand from outside and putting it. There are several important considerations for beach nourishment. Sand grain size and the where you are going to nourish it. With some other solutions may be better. The source is an important parameter for beach nourishment, and where we are going to place it and what method of deploying it, and durability of the sand nourishment or re-nourishment requirement. And sediment grain size is really, really important when you consider beach nourishment. And sand bypassing is if a structure blocks sediment there, artificially move using a pump. This is artificial movement of sand to the downstream beach. Simple method, and rather than dredging and putting it offshore or filling the land, just to feed the nearshore beaches. Like the backpassing, when the sand is blocked there, take it back. This is Mudalapalli in the north and Trivandrum in the north, where it is heavily eroding. Why can't you take sand from here and put it in the south? That's called backpassing. Then moderate cost protection options like offshore reefs. This is an example from Karnataka. 2 offshore reefs constructed. This is about 600 meters offshore from the beach. And this is at 6 meter water depth. And the height is at mid water level. And this structure is a 220 meters, and this is about 250 meters. And the shape is a little bit different depending on the bioclimate. And that has provided a really wide beach in the Lee. Not only the beach, previously the beach erosion, underwater erosion also happened there. And post-construction monitoring actually noticed that the near shore also has decreased the depth or the accreted there. So that's the importance of that structures. If the near shore is still deep, bigger waves can come and break. This near shore steepness was caused by the sea walls there. And here, see, up to 4 meters and 140 meters near shore's covering effect of sea walls, not in the immediate area, much wider and much deeper as well. So 4 meters and required about plus meters or plus 3 means a 4 to 6 meter sediment accumulation, large quantity of sediment accumulation, and in a very wide area. Other options are breakwater, a near shore breakwaters, emerged structures very closer to the beach. And the disadvantage is that it will create a tambolo connect to that. However, with beach nourishment, still it's a good option for several locations, and different shapes are available depending on the use of that. And short normal structures called groins, which we applied quite a lot in the Kerala coast and many other places. And there are straight groins or T groins or several structures depending on the requirements. However, if your surf zone is wider than your groin, it won't work during monsoon time. Non-monsoon time, it will give good result. But the function of this one, if it is not giving good results during monsoon time, this is not effective. So the spacing and the length of the groins is really important if you want to construct groins. I noticed that on most of the groins along Kerala coast is 30 to 50 meters, where your surf zone is 30 to 50 meters. Please do some monitoring and decide how functionally good these groins during storm events. However, if it is maintaining a good beach during storms and monsoon, it's good. But of course, you do need good monitoring data. Seawalls, of course, you are all very familiar. There are rock seawalls, tetrapods, several seawalls are there, and some other seawalls now, rocks, tetrapods, and RCC walls when there's a thickly populated area, and this can be applied, but it is very expensive because steel and cement very expensive. Some other places, buried seawalls also can be considered, especially in tourist beaches where you don't want seawalls to be exposed in normal conditions, but in storm conditions, it will provide as a last line of defense. Still, it won't erode the hinterland. It will protect the land behind it. However, during non-monsoon or dry period, it will look like a normal beach. This also can be considered some of the areas. And hybrid solutions, offshore reef along with the nourishment, tried. This is a more trendy one recently because of the feasibility of such solution and the benefits from that solutions. This is a hybrid solution, Gold Coast, Australia, in Brisbane, the state of Queensland. 50s, 60s, and 90s, they tried seawalls heavily eroding. Then they tried in 2010, actually the planning started in 2000, beach nourishment along with the sand retention structures like offshore reef, and still it is doing very, very well. And the economy of that one is huge. Even they conducted a Commonwealth Games and highly important tourist destinations. So these solutions are available globally. So what is the best coastal protection method for Kerala under climate change? What is...
Excuse me, sir.
Yep.
Sir, ദിവ്യയാണേ. സാറ് ടൈം ഒന്ന് റിമൈൻഡ് ചെയ്യാൻ പറഞ്ഞിരുന്ന കാരണം ഞാനൊന്ന് ചെയ്യുന്നതാണ് സാറേ. 7:20.
I'm going to finish in 5 minutes.
Okay, thank you, sir. Thank you, sir. Okay.
So now you got some idea about the coastal processes and the dynamics and the different coastal protection options and benefits. Some idea, just only introduced. You may read much more reading and more site-specific investigations. Now, what is best for Kerala? That's your job to decide. And let us check some of the characteristics of the Kerala coast. It is seasonal, which we notice that one, and beaches retreat and calm reforms or rebuilt in the post-monsoon. So we need to distinguish between the seasonal fluctuation and the long-term erosion and identify the cause of erosion. And very, very thickly populated. Of course, you all know that one, more than 2,000. So not only the cost of protection, cost of infrastructure, people living there, social important, economic important. So highly, highly important for us to protect the coast in a sustainable way under climate change. See, if you take the coast, it is more sandy in the nearshore area. And especially central Kerala, very low lying, central and northern Kerala, very low lying as well. If there's a small increase in the sea level rise, all these areas can be inundated or flooded. So our coast protection should consider the low-lying coastal areas. So the coastal structural selection should consider flooding of the hinterlands. This is another map showing the low-lying areas of central Kerala. And this for several kilometers, this Kutanad area in northern Kerala, central Kerala, most of these areas are low-lying. So these areas can be severely affected. That's why you notice recently from many of the IPCC reports, the impact on Kerala coast. And we do have many rivers, but the river input, sediment input is very limited. And our shoreline orientation is different for different locations. So the exposure to waves and currents are different. And some areas like Trivandrum, we get monsoon, non-monsoon, totally different angles. But in central Kerala, we may get monsoon waves straight on shore. So the longshore transport may be very less here, but longshore transport very high here. So we need to have really good idea about the longshore transport, its relationship between shoreline orientation and wave approach angle. That's why severe erosion identified on the Kerala coast here in the southern Kerala and some in the northern Kerala, depending on the shoreline orientation. Several studies readily available, and the wave energy along the Kerala coast, high energy in the southern coast, like D is the low in Cochin and Calicut, Talasheri area. So some of the erosions may not be due to erosion, but due to other effects. And it's like we had only 4 ports or fishing harbors in 2000. Now we got about 24 or 25, including Cochin Port, 25. So 25 means 30 or 50 breakwaters. So all these have significant impact on the longshore sediment transport. And some monitoring by NCCR Chennai, they noticed on either side of these coastal structures or port structures, erosion. So the erosion is man-made and natural. And this is the report recently published, about 374 square kilometers Kerala's coastal land may be submerged by 2130. I think it will be much more and much before. And not only inundation, water level has significant impact on the coastal erosion. And can we afford that one? And we had predictability of the waves. And now, because of the cyclones coming from different directions, that has gone. Even though it is only for a shorter period, if it occurs after the monsoon, it will delay the post-storm monsoon beach recovery. That exactly happened after Cyclone Oki, which means that some of the sand can be moved further offshore and lost from the system forever. And our earlier designs were primarily for monsoon waves. Now we need to consider for cyclones as well, not just monsoon. Many would say that, oh, cyclone is only for 1 or 2 days. That 1 or 2 days enough to create enough damages like this one. If you have a structure like this one, when the waves coming from the south, north of the structure will erode. And if the waves coming from the north, south of the structure will erode. So this is called end effect or terminal scar. And if you do structures for longshore erosion, sorry, cross-shore erosion, it will not protect the longshore erosion. So the new designs and coastal management should consider both longshore and cross-shore. Cyclone Oki, December 2017, and next cyclone occurred in May, just before the monsoon. And this is Trivandrum. The beach did not recover fully, and the effect was this one, and further erosion after that one. So we get long dry period. And if the sand is moving further offshore, it is not recoverable. In addition to the mining and dredging and other man-made activities, because of these natural reasons, also we are losing sand. And normally it should form an offshore bar and it should come back. Now, if it is going further offshore, beyond the wave base, it won't come back. So it will be a permanent loss to the system. That is why the Trivandrum Shangamugam beach, one of the popular beaches in Trivandrum or in Kerala, hundreds of people go there every year, every day and every weekend. And now the situation is like this one. Previously 80, 90 meter wide beach there. Now absolutely no beach, plus the coastal eroded half of that one. And this is Trivandrum airport. And next it is going to affect airport. So what we are going to do? The coastal protection is not the beach protection. It is the entire coastal area. If you lose a coastal infrastructure like the airport or coastal road, what would be the economic impact? This is something I said about the groins of it. Summertime, we get really nice beach and sand accumulation in the groins. But storm or monsoon times, there may not be any beach. So whether the groin or the seawall, which one is protecting the beach? So when you design coastal or shore normal structures, make sure that structure will give protection during storm events as well. Monsoon time, you don't need any structure. First of all, there's the wave activity very low. And second thing is that normally there's a beach there. But if this beach can be maintained throughout the year, irrespective of the monsoon or non-monsoon or storm, then it's a good option. That's why really good data collection is important and understand the system. And now the changed wave climate. Earlier, it was only monsoon, southern, and Chanel. Now we got the additional factors from the south and northwest, and waves coming from all the directions and storms. So we need better understanding. And during cyclone times, the wind setup, along with the storm surge, huge inundation happen. And the wave run-up can be several meters to the coast. So we do need to have an idea about the minimum beach level, which is completely based on high tide, storm surge, wave setup, sea level rise. Then your design structure should have a full idea what is the minimum beach level, whether it is for coastal road or house construction or coastal protection structures. Identify the minimum beach level of that area. And also dynamics, not just simply the exchange now. Where should be your structure or the safe zone? Your erosion profile till now was somewhere at XC. Now we need to get an idea or the probability of XC crossing XG under climate change and storm sea level rise. So coastal planning should have a better idea. So let me conclude with these ones. The challenges under coastal climate change for coastal protection, and coasts are very sensitive to sea level rise and the frequency and intensity of the storms, and beaches are in a state of steady recession. This is from the previous 10, 20, 30 years of data. And restore the natural sand supply and creating a stable beach for present and future use is really challenging because of the scarcity of the sand. Impact of climate change, the coastal areas of Kerala are projected to result in rising sea level, and in some areas, changes to the wave and storm surge regimes. If your water level is going to increase 3 to 5 meters, bigger waves can come closer to the beach, and not only inundation, huge erosion also can happen. These changes are projected to result in higher water levels and increased erosion due to higher waves and stronger currents. So addressing the additional stress of climate change is really important. So we need to have good understanding about the sediment transport process, coastal process, and offshore bar decay, where the offshore bar is going, whether that sediment is going to come back. And water levels definitely have significant impact on the sea level, so it's erosion. So selecting an option for Kerala, we do need site-specific investigations, not 1 or 2 days or years, consider for a longer period and consider the climate change impacts as well. And sea conditions are different for different locations, so don't take one measurement for our location. And your design should be for that particular location. And I explained the importance of data and the quality of the data and sufficient duration and the maximum information required. The data is going to decide the quality of the output. And the climate change is really important for coastal infrastructures, protection of the infrastructures. And traditional approaches, please think about one, whether this is enough under climate change. Do we need to change? Do we have other options? If we do have innovative options, what are the options available? Thank you.
Thank you very much, sir.
Yes.
Sir, time limit sorry പറയുന്നു കാരണം ഇനി ഒരു സെഷനും കൂടെ ഉള്ളത് കൊണ്ടാണ് അങ്ങനെ ഒരു ലിമിറ്റേഷൻ സാറ് പറഞ്ഞ പ്രകാരം ഇടയ്ക്കൊന്ന് റിമൈൻഡ് ചെയ്തത്. ഓക്കെ സർ, ഇനി ടൈം ടു ഡിസ്കഷൻ ആണ്. പാർട്ടിസിപ്പൻസിന് സാറിനോട് എന്തെങ്കിലും ക്ലാരിഫിക്കേഷനോ ഡൗട്ട്സോ ഉണ്ടെങ്കിൽ ചോദിക്കാം.
My apologies, I needed to rush a little bit and because of that internet problem and time limitations. Anyway, I'll try to answer quickly if a few questions I can take. You can ask in Malayalam if you want to.
Good evening, sir.
Yes, good evening.
My name is Ajay. I'm from MI section Kalpata, minor irrigation section. Can you hear me, sir?
Yes, yes, I can. Please.
I just had a small doubt. While you were presenting, you showed us a diagram where you had arranged tetrapods and you had an RCC wall behind the tetrapods as a hard coastal protection.
Yep.
Yes. So, is there any special consideration for designing such a concrete wall, or is it just an ordinary RCC wall?
Okay, definitely quite a lot of considerations for that one. First one is your toe selection and the armor blocks for the selection, because of most of the wave breaking, the maximum force will be, or the most vulnerable section will be the toe factor, and your toe should be really, really strong and elevated as well. And the tetrapod size also, under bigger wave climate, it can fly. And I noticed that when in Mangalore, even 2.5 ton tetrapods flew from the structure. So your tetrapod selection should be really important, and interlocking and placement of that one really, really important. And the shape of, you might have noticed that one, the shape of the tetrapod in our case, it is a hexagonal shape, not round shape, because we wanted more reflection from that one. And your RCC wall, remember, you are going to construct the RCC wall on an unconsolidated bed. Make sure that it is sufficiently deep, and you are going to get waves, and that wave force is too strong. And if your RCC wall is not sufficiently deep and with good base and really thick, it can break easily. Even though the tetrapod and all other things are there, a small increase in the water level is enough for overtopping. That overtopping is enough to damage your concrete walls. And you notice that when, because of the overtopping, many concrete houses damaged or collapsed. If that concrete houses with that base can be collapsed, then you can imagine what's a small. So the base design is really, really important, especially you are constructing something on a sandy bed.
Yes, sir. But what about the foundation, sir? Should we have a foundation of a greater depth for such a wall? Since because the soil is less consolidated than an ordinary soil.
Yeah. Foundation is really important. And in that particular case, even though the land was at +4 meters, I think, our foundation level was about 0 meters. That should be a strong one. Depending on your site. Otherwise, it will damage quickly. Even the entire wall can collapse. And the reason why you're going for walls is the houses are something very close to your shoreline, and it can create further damages. So designing that one is really, really important, and go for that one only if it is absolutely necessary for 2 reasons. One, it is very expensive. Second thing is that unless you do a very strong one, the chances of damage is very high.
Okay, sir. Thank you, sir.
Thank you, Ajay. Any other questions?
Sir, good evening, sir.
നമുക്കൊരു ഈ ഒരു സെഷന്റെ കൺക്ലൂഡിംഗ്
I think one more question from someone.
Tell me.
Sir, my doubt is regarding the construction of drawings. Say, suppose I have a 10-kilometer stretch, vulnerable stretch, and I have decided to go for a drawings on them. But due to some reason, say the number of drawings were limited, so the effect of end effect will be predominant in the downstream end. So how can I reduce these end effects?
Okay, first of all, you need to decide whether groin is the best solution for that area. Whether the groins are going to retain sand even during monsoon time or storm events. End effect groin field, that's a typical method people use, provided you do nourishment. If you do groins, I strongly recommend do nourishment as well. Otherwise, groins will capture sediment, natural sediment transport, which will exacerbate erosion. So you fill the groin compartments with sand or with nourishment that will minimize downstream impact. Secondly, go for groin field, the size of that one, decreasing size. The nourishment is a very important component if you go for groins. In other words, you should not allow trapping of sediments on one side or natural capture of sediments by the groin compartments. Allow that natural capture, natural sediment flow, then your beach will be stable, if it is stable.
Thank you, Akhilesh. Sir, നമ്മുടെ ഒരു കൺക്ലൂഡ് ചെയ്യാം, കാരണം ഇനി ഒരു സെഷനും കൂടെ ഉള്ളത് കൊണ്ടാണ്.
Please go ahead.
ഓക്കെ സാറേ, സാറേ ഇന്ന് നമ്മുടെ ഡയറക്ടർ സുപ്രഭ മാഡത്തിന് ഇതിനകത്ത് ക്ലാസ്സിൽ ജോയിൻ ചെയ്യാൻ സാധിച്ചിട്ടില്ല. കാരണം ഒരു അർജന്റ് എമർജൻസി വർക്കുമായിട്ട് ബന്ധപ്പെട്ട് കുറേ പേരുണ്ട്, കുറേ ടീം അംഗങ്ങൾ സൈറ്റിലാണ്. അപ്പോൾ അവർക്കൊന്നും ജോയിൻ ചെയ്യാൻ പറ്റില്ല. അപ്പം മാഡത്തിന്റെ വക ഒരു പ്രത്യേകം താങ്ക് യു സാറിനോട് പറയാൻ വേണ്ടി പറഞ്ഞിട്ടുണ്ട്. താങ്ക് യു വെരി മച്ച് സാർ ഫോർ ദി പാർട്ട് ഓഫ് KERI. ദെൻ പാർട്ടിസിപ്പൻസിന്റെ സൈഡിൽ നിന്ന് സാറിന് താങ്ക്സ് പറയുന്നതിനായിട്ട് അജയ് SR മൈനർ ഇറിഗേഷൻ സെഷൻ കൽപ്പറ്റ AE-ന് invite Ajay. Ajay, please, Ajay.
Good evening, everyone. I am very fortunate to say that this is one of the best technical presentations I have attended in my professional life, and I'm pretty sure everyone feels the same. We had a very interesting presentation today, which was very tightly packed with great attention to detail, with a lot of diagrams, color-coded diagrams to explain the most simplest as well as the most complex of concepts regarding coastal engineering. Sir, you have dealt with one of the most powerful, creative, and destructive force of the nature. And it is no simple task. What a person takes probably months and months to learn, you have explained such concepts in an hour or so. We had a brief interruption for the session, but it was a tiny speck of dust compared to the massive inflow of information coming from you, sir. And I would, from the bottom of my heart, and on behalf of all the assistant engineers who have joined this session, I would like to thank Dr. Joseph Mathew, sir, for letting us have a bite of a major chunk of your expertise, sir. Now, we are yet to see one of the worst climate changes probably of our lives in the future, and I hope we will all be prepared for it. Thank you very much, sir.
Thank you, Ajay.
Thank you.